This is 6.5 Law of Cosines. You are going to need your own sheet of paper for this. You can start using a spiral or just notebook paper, but make sure that you have your own sheet of paper. Okay, so in class, what we did yesterday or today is we discovered the law of cosines. So I'm going to make sure that you understand these. So first of all, I want to draw a triangle, and this is not a right triangle, this is just a random triangle. I'm going to label it ABC. Remember that when you're drawing or labeling triangle, capital letters go on the outside, and then across from the capital letters are lowercase letters. This is true for any type of triangle. Okay, so this is just a random triangle. Okay, so what we discovered is, I'm going to start with A. This starts out kind of looking like Pythagorean. You've got a squared is equal to b squared plus c squared. Then you're going to subtract 2. You're going to multiply it times the product of these two letters right here. It doesn't matter the order, times 2bc. Then you're always going to multiply that times the cosine of the letter that you always started with. So cosine of angle A. Okay, you can use this from any angle. So I'm also going to rewrite it as starting with angle B. So side B squared. Then you're going to use your other two sides, so a squared plus c squared, and again that doesn't matter the order. You're going to subtract the product of these two letters, so AC. Then you're always going to multiply it times cosine of your beginning angle, which is B. Okay, let's go ahead and write C. So c squared is equal to the product of the other two sides, so b squared plus c squared. You're going to multiply it times 2. B plus, or sorry, product of B times C, cosine of angle C. And you're going to use this anytime that you want to find angles or sides. We're going to be finding sides first, but later on you're going to see that you're going to be finding angles as well. All right, so let's use this to find something. Okay, so I'm going to draw my random triangle here. It's a bad triangle. Let's start off by using this is 388 and this is 212. How about we say that this is X and this is 82.4 degrees to make it just totally random. Okay, so the first thing that let's talk about is let's find X. That's your directions. And I know I don't have the angles labeled, but I really don't need them. And the first thing I'm going to ask you is if this triangle is unique. Is this triangle unique? And what you should be looking at is, or what you should look at here is, yes, it is unique. And way back in geometry, you have found that this is a unique triangle because of side, angle, side. So there's no other triangle that can be made like this. Yes, because of side, angle, side. Okay? There's no other triangle that can be made exactly with these measurements. Okay, so in order to find X, what I look at is, remember these were made, these formulas were made by looking at the angle and the side opposite. Okay, so it doesn't matter which one of these that you try. If you would like to label all these by doing ABC, that would be helpful for you. That's fine. What I think about is I'm going to start with an X squared, and then I'm going to end with cosine of this. Okay, so X squared is equal to my sides I'm going to add, and it doesn't matter which one you start with. So this is 212 squared plus 388 squared minus 2 multiplying by the product of those two numbers, so 212 times 388. And then I'm going to do cosine of the angle opposite of where I began, 82.4. Okay, at this point, make sure you can use your calculator, but it must be in degree mode. So what I did is I go ahead and type this whole right side in my calculator all at once. when you type it in, go ahead and do that. Make sure, I want you to make sure that you get this crazy long number so that everybody is on the same page. You notice that you have x squared, so that you must square root it. And when you square root, I got approximately 416.81. If you're ever going to use this number again, I would store it because we are rounding. But at some point we are going to use it again, but I just wanted to find the other side. I could not use Pythagorean because I don't have a right triangle. So therefore, I had to use the law of cosines. So this is what you should get. Pretty simple. All right, let's try another one. Okay, again, I'm drawing a random triangle. Kind of looks equilateral, but I'm going to give you some letters this time to help you out. Let's try y is 8. Let's try x is 5, and let's try z is 12. Again, I'm going to ask the question, is this triangle unique? Can there be any other triangle that can be made like this? So it looks like this is unique, and it's unique by side, side, side. Okay, so what I want to do is I want to find my missing angles. What angles give me this specific triangle? So I'm going to start with x. Just randomly, you can start with any other one. So if I start with x squared, let's see. Remember, when you start with x squared, you start with the side opposite. And if you need to, you can change the letters at the beginning to be x squared, y, and z. In fact, let's do that so it makes it easier with you. So this is y squared plus z squared minus 2yz, and this is going to be cosine of your beginning side, which is x. Okay, so this is going to be x squared, so this is going to be 5 squared. This is going to be your y, so this is 8 plus 12 minus 2 times 8 times 12, and this is cosine of my missing angle, which we do not know, so this is cosine of y degrees. Okay, I'm looking for cosine of my angle. So I'm not going to find these values. You're going to find that it's a whole lot easier if you go ahead and just solve for cosine of y degrees. So in order to do that, I'm going to have to subtract. Order of operations says subtract 8 squared and 12 squared. So I'm going to do some things all at once. So I'm going to subtract 8 squared and 12 squared. That gives me negative 2 times 8 times 12. And I still have cosine of x degrees. Still looking to solve for cosine of x degrees. Okay, I'm going to do some more things in one step. It looks like in order to get cosine by itself, I'm going to have to divide by negative 2, 8, and 12. So this is 5 squared minus 8 squared minus 12 squared divided by negative 2 times 8 times 12, and that will give me cosine of x degrees. All right, and then the last thing, if I really wanted to find cosine of that, I would have to move my, if I wanted to find out what x was, I'd have to move my cosine over. So to find the measure of angle x, I would do an arc cosine of 5 squared minus 8 squared minus 12 squared over negative 2 times 8 times 12. Okay, your calculator is still in degree mode, and if you would like to plug this in, so that's 25 minus 64 minus 144 divided by negative 2 times 8 times 12. If you want to plug this all in at once, make sure that you're using parentheses on the top and parentheses on the bottom. So you're going to have to double up on your parentheses. I got the measure of angle x is equal to 17.612 degrees. Okay, since we are going to find every angle of this triangle, for right now, I want you to go ahead and store this because we're going to use this for later. So store this into X. Okay, now I want to go ahead and find your Y value. So I'm going to move this over just a little bit and see if we can find Y. So I'm going to jump down here and see if y'all can figure this out. So to find Y squared, that's going to be X squared plus Z squared minus 2 times X times Z minus, whoops, I don't need a minus there, times cosine of Y. Okay, if you would like to jump to the formula, in order to do that, remember we did Y squared minus X squared minus Z squared over negative 2 times X times Z. Then we took the arc cosine of that. So I'm going to jump ahead there. We took the arc cosine. That should give me the angle, the measure of angle Y. Okay? So I'm going to go ahead and fill my information in here for the measure of angle Y. So my arc cosine would be 8 squared minus X squared would be 5 squared minus Z squared would be 12 over negative 2 times X, which is 5, times Z, which is 12. Okay, to give you a minute to plug that into your calculator, the measure of angle Y, it looks like is going to be 28.955 degrees. Now the nice thing about this is now that we know X and Y, to find the measure of angle Z, we just need to do 180 minus each of those because all three angles add up to 180. And I found this to be 133.433. And now you have all angles of a triangle. Okay, so now that you've used the law of cosines, let's look at area of a triangle. Now, I know you're used to using area of just a right triangle, which is just base height over 2. But that's a right triangle, correct? Or you can make a right triangle out of it, where this is your height right here, and then this is your base. But since we don't really know our triangle and what it looks like, we're going to have to use a new formula, which is abbreviated just a little bit. So I'm going to say area equals 1/2. We've got, it depends on what angle you're looking for. I'm going to say side B times side C, and I'm going to say sine of angle A. Okay? If I were to, now remember I can change this up. If I were to look for angle B, then I would say A times C sine of B. And again, I can change that up more. If I'm looking for angle C, then I'm going to say 1/2 B times A sine C. So if you notice, I'm just making sure I use all the letters. Angle A, here's BC, B, here's AC, and so forth. Okay? My last problem, what I want to do is I want to find the area of triangle XYZ in problem number 2. And let's pick, you can pick any angle. I don't need to say that. Just find the area in number 2. So let's go back to number 2. we have every angle. We have X, Y, Z. We have all the sides. So you can pick any angle that you want to. Now remember, I did tell you to store angle X right here. Okay, so if I told you to store angle X, that should help you out. So if I were to draw this triangle, this was X, Y, Z, just to kind of give you an idea. This was this side, and here was 12, and I stored this angle right here, which was 17.612 about. So to tell you how to use this formula, area is equal to 1/2. If you have an angle, your angle is going to be surrounded by the sides. So if this is angle A, this is going to be BC. This is A, B, C. Your little b's here and your little c's here. So whatever angle you're looking for, the sides are going to be surrounding it, which is really nice. So I'm going to say 1/2 times 8 times 12. The main thing is to make sure that you use sine on this problem, sine of your 17.612. Now remember, you're going to use the stored version that's already in your calculator. You plug this straight into your calculator. So you'd say 1/2 times 8 times 12 times sine of your X value, because that's stored. So your area is approximately 14.524, and this is units squared. And that's it, guys.